Hello everyone, my name is Elif Asar and I am a PhD candidate in Mechanical Engineering Department, and my advisor is Professor Jamal Gubi, and I will be presenting Reducing Carbon Footprint of Energy-Intensive Industrial Drying by Smart Dryers. So when you think about drying, probably first thing that comes to mind is laundry drying. But I'm not talking about that. I'm talking about intensive industrial drying. So paper, food, and pharmaceutical manufacturing requires a drying process, which is very energy intensive. But today's presentation, I will focus on paper drying, but keep in mind that the technologies and the novel drying methods that I will be presenting is also applicable to other industries, so which makes the scope of this research even bigger. Are you aware how manufacturing a piece of paper impacts the environment? Well, paper manufacturing takes up a quarter of the industrial energy used in the United States, and 70% of the energy used in paper making is for drying paper. Every day, around 2,000 tons of carbon dioxide is released just to dry paper. To capture the emissions for one day, you must grow 100,000 trees for 10 years. That's outrageous. But my research comes in handy here because I'm working on dryer technologies that decrease the total energy use of drying products and decline the emitted greenhouse gases. Even 1% enhancement makes a significant difference. With this in mind, I leveraged the principles of fluid flows and thermal engineering, and I utilized a previously developed and optimized nozzle called slot jet reattachment nozzle, as you see it over here. The unique way that air passes through the nozzle heats up and dries the moist product very efficiently. Normally, if you were to go inside a paper machine, your glasses would fog because of the humid air, but these nozzles can also clear the humid atmosphere, and thus paper dries faster. In my validated drying model, I included these nozzles into the paper machine in an applicable way for the industry. So far, my analysis has discovered that when these nozzles are combined with the paper machine, paper's total drying time decreases by 10% as seen here. This roughly means 9% energy savings, and which reduces the emissions by 200 tons per day, which is amazing. But can this be further improved? Yes, of course. This is where smart dryers come into play. In the next steps of my research, I aim to develop smart dryers employing various novel drying methods. In addition to the nozzles, I will dry samples without applying heat, but applying certain sound waves or applying electric current, both with minimal energy consumption. Well, how do I combine all this? I'm going to use artificial intelligence and innovative sensor technology to predict the best combination of drying methods. In this way, the 9% energy savings with nozzles is projected to climb up to 30% with smart dryers. In conclusion, my studies are targeted at minimizing carbon footprint of drying by building a bridge between the emerging technologies and the industry. And thank you very much for listening.